Okay, guys, we're going to do little notes over distance. Okay, so we've talked about line segments. We talked about midpoint. Now we're going to talk about distance. Okay, so we're going to do distance on a number line and then distance on a coordinate plane using two different methods. Okay, all right. So on a number line, it's very easy. It's really just counting. Again, we just have one axis here. This would be X, okay, a horizontal axis. So there's a number line, all right? So what is the distance from -7 to 3? Well, count them. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 spaces between those two. So find AB, all right? That would be the distance between A to B, whatever, that would be 10, okay? So can distance ever be a negative value? The answer there is, of course, no. Distance is always positive, guys. So think about somebody walking across a room going forward. They would be walking a distance, right? Well, imagine if they turned around and they went backwards. Well, they would still be walking a distance. Distance always adds up. It doesn't matter what direction you're going, okay? So if you drive to the store, you go a distance. Well, if you drive home, just because you're back where you started doesn't mean you didn't travel distance to get home. So distance is always positive. Can distance be a negative value? No, 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 okay? All right, so what is the distance from like -3 to +9, okay? Now, you can stop at 0 here. So I know from -3 to 0 will be 3 spaces. From 0 to 9 spaces will be 9. So we add those two together. All right, what we end up with is 12, okay? So, but basically it's just counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Boom, okay? Number line's easy, all right? Now, when this gets complicated is when it asks us to do it on a coordinate plane, okay? Now, there's two ways you can do it, guys. And the way I highly suggest is this first one, which is the Pythagorean theorem, which we all know, and I have it written over here already. A squared plus B squared equals C squared. Now, what I'm going to do, guys, is I'm going to be using a derived version to be able to find C, because C, the distance between these 2 points, is always going to be the hypotenuse of my right triangle. And again, I'm going to show you where that right triangle comes in, because in order to use Pythagorean theorem, we have to be talking about right triangles. Pythagorean theorem will always work for right triangles, okay? Where my right triangle, okay, would have leg that was A, B, and the hypotenuse would be C, okay? So that's what I'm talking about there, guys, all right? Now, let me show you how we're going to do this. Whenever we're looking for distance, guys, you're going to draw the actual distance, then you're going to draw on your figure, and it might be a little difficult for you to see, your horizontal and vertical lines that end up making a right triangle. So everybody should be able to see pretty much. Let me move where you can see a little bit better. Okay, we drew a right triangle, okay? So we're going to use whatever this measure is here for the A, whatever this measure is here for the B, and then we're going to find C, which would be the hypotenuse, which would be the distance. Now, again, I'm using a derived version. All I did was take the square root of both sides to get rid of this C squared. So C equals the square root of A squared plus B squared. This is going to make it a billion times faster for y'all when you're actually finding distance. So when you're doing distance, use this formula right here. It's a derived version of the Pythagorean theorem, A squared plus B squared equals C squared, okay? All right, now let's look at this first example here, guys, okay? So it says find the distance from -3, -2 to +3, +2. So I'm going to use the Pythagorean theorem. So I'm going to draw my distance that I'm actually looking for there. Then I'm going to draw my vertical line, okay? And my horizontal line to make a right triangle, okay? Now, from here on out, guys, it's just easy counting. Let's see how long our vertical line is. So that'd be 1, 2, 3, 4 spaces, okay? So my A is going to be 4. My horizontal is 1, 2, 3, 4, 5 spaces, okay? So my legs are 4 and 5. So now all I have to do is find my C there, okay, which would be the hypotenuse of my right triangle. So here we go. C equals the square root of 4 squared plus 5 squared, okay? Now, if you have a graphing calculator, guys, you can just plug that straight in and hit enter. If not, you'll have to evaluate it, but that's not that big of a deal. It's just square root of 16 plus 25, which would be the square root of 41, okay? So we end up with here, we get 6.04, all right? So 6.4 is what we get, okay? Rounded, okay? So my actual distance here, my C, my distance, okay, is 6.4. That is the distance, guys. And again, it's very, very rarely will you have a whole number there. We're going to be dealing with decimals here. Round to the nearest tenth for me, please. Okay. Now here on this next example, this is a you try it. Okay. So at this point, go ahead and pause the video and give this one a try, where we have my distance of -4 or -5, -4, and -1, +3. Find the distance between those 2 points. Okay. So draw yourself a little graph. See if you can solve this one out on your own without any help. Okay, for those of y'all who did not pause the video, here's the explanation, all right? So we have -5, -4, all the way down here on the left, okay? That's our first point. -1, +3, over here in the second quadrant, all right? So there's our 2. So we draw our distance, okay? Now here, I'm gonna go over and down just to show y'all that we can go different directions, okay? It doesn't have to be down then over, it could be over then down. So this, again, we could have a reflection, this right triangle here drawn as well, okay? Well, I count, I have my legs are 1, 2, 3, 4. 4 there, going down, 1, 2, 3, 4, 5, 6, 7, okay? So 7 there. So my distance here, which I'll call C, my hypotenuse, I'm using Pythagorean theorem, C equals 4 squared plus 7 squared. Now, when you evaluate that one in the calculator, guys, what you end up with there is C equals 8.1, okay? 8.1 would be your distance there, okay? And again, you're just finding it, finding the legs, using your drawing the right triangle method, find your leg distance, square them, add them up, take the square root, evaluate this Pythagorean theorem, version of the Pythagorean theorem, and then that's it, y'all. Okay. All right. Last little piece here. And this is the explanation of using the distance formula. Okay. Now you see you have x2 minus x1 squared, y2 minus y1 squared, all under the square root. Well, where those x's and those y's come from are your coordinates. So whenever you're using the distance formula, always label your coordinates x1, y1, x2, y2, okay? Now, order doesn't matter. This could be x1, y1, this could be x2, y2, but your 1's need to be together and your 2's need to be together, okay? So when we evaluate this one, guys, I'm just going to write it in as the distance formula, and really you could just plug this into your calculator if you have a graphing calculator. So here we go. Let's write this out on paper first, okay? So I'm going to take my x's, all right? So this is going to be +3 minus 2 squared plus, now my y's, all right, well, we're going to have a little issue here. So this is 4 minus -2 squared, okay? So that minus a negative, okay, 4 minus -2, that's going to turn that into a positive. So when I write this out, I'm just going to write 4 plus 2 in the parentheses, okay? Now again, once you have your graphing calculator, beep, 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 you plug it right in, you immediately get your answer. If not, you're just going to have to evaluate it. Again, 6 squared, okay, 4 plus 2 is 6, that would be 36. 3 minus 2 would be 1, okay, so really this is the square root of 1 plus 36. You see I just evaluated what happens. 6 squared, 36. 1 squared is just 1, okay? So this would be the square root of 37, okay, which is going to approximately equal 6.1, okay? So there's your distance found by using the distance formula. Again, just label your points and then evaluate it in the distance formula. Here we solved it out on paper a little bit. If you have a graphing calculator, you can plug it right in exactly as it appears here and hit enter. Boom, you're done. Okay. All right, guys, so that's distance on a number line, which is just counting. Distance on a coordinate plane using Pythagorean theorem, which is right triangles, okay? So there's 2 examples of that. And then we have distance using the distance formula. Here it is. Make sure you have this written down somewhere, okay? You always get to use this. I'm never going to ask you to be able to do a quiz or a test without giving you this first. So it's always a great idea to have it written down since everything you're doing at home is virtual, okay? All right, guys. Have a great rest of your day. Bye.